Hi, welcome to the IntelliParts Data Science course program. So this is the module 1 where we will get an overview about analytics or data science. We will get a clear end-to-end picture, an high-level picture about what the data science actually is and why the term became so popular nowadays, which was not there earlier. So before actually jumping into the module 1 directly, I just want to walk you through the prerequisites for the data science program and what are the expectations from you before actually starting with this program or the course. Believe me, it is not data science is not so difficult as you might think. There will be a continuous process of learning, applying, and iteratively uh, working on the data to bring some value out of it or to solve a business use case problem. So we are assuming that you have completed the statistics part already, and also you have some enough or at least a basic knowledge in R programming, as we are going to do our all our practicals or case studies in R only. For very few things, we will perform some tasks in Excel as well. That is very less though. So it is highly recommended to have a good hands-on in R programming. At least you should have the basic knowledge, basic idea of how to write the program. If you have the fear of coding, I just want to suggest or recommend you to get out of the fear of coding in order to become a good data scientist. You don't need to write thousands of lines of code all the time, but writing 100 or at least 50 lines of code should not be something that scare you. You should be at least feel comfortable in logical thinking or how to uh, build a code snippet for some particular module. You should be able to feel comfortable for those kind of things, and I want you to get ready for those kind of things. So irrespective of your academic background and experience, this course content is designed in such a way that everyone can easily understand and cope up with. At least I think so. So, as far as data science is concerned, data science can be learned in many different ways. So, one is deep mathematical way, where a person spends a lot of time understanding the base of the algorithms, the underlying maths behind the algorithms. He will try to derive from the scratch all, like it was very scary mathematical way where a person spends a whole semester understanding the regression concepts itself. So that is one way of learning data science, and the second way is high level learning, which might be suitable for the managers and other high level experienced or expertise people, where they just have the idea of what models, how they work, what kind of models to be used in what kind of scenarios or what kind of use cases. They will have just the basic high level idea about the data science. Here the main emphasis will be on what questions should I ask to the business user, what answers should I derive from them, how to relate the things with their business, and how to come up with a particular solution for the business use case, and how to put forth that solution so that that can bring some value to the business. So that everything will be on high level, say 1,000 feet above level. And the third one is engineer's way of learning, where you should learn enough science, learn enough business as well, and with the goal of putting things together, bring all your science knowledge and bring your business knowledge, put them together, make some assumptions based on the problem scenario, develop the models, and come up with some approximations, test the model. If it is successful and meeting the business criteria, deploy it and update it regularly. So These are the three main ways of learning data science. And this content is designed to work on the type 3, that is, where it covers enough science which you can learn and apply in real time scenarios. And apart from this, we recommend you to spend a lot more time on self learning as well as the preparation as well. Preparation in the sense, I recommend you to do these things practically. Uh, you should be able to, after completing of the entire data science course, when you see a problem scenario, you should be able to tell what are the steps I should follow to get into the solution, and what are the possible algorithms can I use for a particular problem scenario. So you should be comfortable in that level at the end of this entire data science course. So these are the expectations and the prerequisites on a high level, which are required in order to start with this course. So let's get started with module 1, overview of analytics. So this is the agenda of this module 1, where we will learn meaning of data science, like what actually the data science is, why the term became so popular nowadays. And the second thing is the scope of analytics, like how many kinds of analytics are there, and which analytics technique to be used in which kind of scenario, and how these are applicable uh, throughout the problems of an organization. We will see different kinds of analytics, and we will see some examples. Next is the applications of analytics. Like what are the various areas where you can apply analytics. We will see some domains like finance, retail, HR, telecom, and we will see some useful example use cases. And next is the advanced analytics. Like we will just go through briefly um, what are the career paths for analytics professional, and what are the pre-learnings required, how what should be your learning path. So those kind of things we will see. So this is mainly the agenda of module 1. So let's get started knowing what data science actually is. And before that, before knowing what data science actually is, let's focus on the problems with organizations or every business. So organizations have many problems nowadays, and before getting into the actual data science definition, let's go through the organization's problems so that we will understand the importance of data science and its popularity. So this is the first problem. Like organizations have all the data, but they don't know what to do with that. We know since the evolvement of IT, when say since 1960s or 70s, the time when the systems or the processing systems have started, organizations have started storing and processing a lot of data. They've invested a lot in setting up their IT infrastructures, both in terms of hardware as well as in terms of software. The IT systems in every business collects and stores a lot of data. They process a lot of data, and the data flow also into the system increases enormously every day. For example, if you take the number of transactions in a bank, like each and every bank performs millions of transactions through different kind of input sources, and banks also stores each and every transaction for their business benefit. Or say in another case, Walmart, which is one of the retail majors, process some millions of transactions per hour. In that way, if you calculate the transactions per day, then it will be very huge, and per month it will be even more huge. So similarly, the transactions processed by stock exchanges and other major telecom organizations, or say all the business, the data will be very huge. So they store all of this data in their IT systems. Now, each and every organization wants to bring some value out of the data. So, the storing and processing the data is fine. That is just to perform the day-to-day transactions and to process the data. That is fine. But just storing may not bring some additional benefit or additional revenue for the business. They want to use this data to bring out some value from that. So this is one major problem every organizations or every business have. Like they have all the data, but they want to know what they can do with the data, with this existing data. And the next is they have implemented a lot of customer service centers and customer call centers and customer CRM systems. So, and those systems started collecting a lot of data from their customers. So, what organizations feel is okay, we have set up all these things, all these centers or CRM systems to serve the customers. So, how we can get a real benefit to the business? Storing the data is okay, but how we can derive some useful benefits? And the third is how do we become a customer centric organization? So how we can serve our customer better and how we can retain the customers and how we can reduce the customer churn. Customer churn is in the sense customers leaving our organization, how we can retain them back and how we can increase our customer base. So that is also one major concern each and every organization feels. And next is, yeah, this fourth point which we discussed as part of the first one, we invested a lot in technology and other resources, like resource in the sense it can be hardware or software or manpower. So all the resources they have invested a lot to store and process the data and to do their online transactions like daily transactional process. But what kind of real benefit they can give? So they want to know that. And the next is, yeah, this is utmost important for each and every business. They have their competitors in the market. So how we can deal with them, how we can better service the customers to beat our customers, and how we can come up with better offers to attract the customers to beat the competitors. So these are not the complete list, but these are some of the major problems organizations have nowadays. Now, okay, these are the problems. How data science can help organizations to address these problems. So, data science is nothing, it's not about a tool or a software. Data science is a science of, it takes the concepts and theories and techniques from many fields like mathematics, statistics, or operation research, data mining, machine learning, statistics, and many more fields. And it takes the concepts and theories and techniques and apply on the data and find the hidden insights and come up with some approximations. And these approximations or findings will help the business to make some decisions which can further bring some revenue to their business. So data science can directly or indirectly help addressing the problems each organization is having now. Yeah, we know that data science is an interesting, exciting, and interesting career path nowadays. And we know that Gartner has listed it on the top. And also in US in the 2016, data science remained as the top one admired job in the US. So this skill requires some prerequisites, like data science requires some prerequisite skills, and one major prerequisite skill is the mathematical skills. Mathematical skill here doesn't mean learning all the maths. It just requires, say, some basic knowledge maths, like which you might have learned in your academics, a kind of coordinate geometry, basic level of coordinate geometry, and the linear algebra, which includes vectors. What is a vector? Why? What are the matrices? The matrix multiplication, all the basics. Even if you don't have any of those concepts in your mind, then it's okay. No need to worry. We will just start with the basic maths first before going through technique. Suppose we are discussing about the principal component analysis, we will first touch up the what the vectors are, what the matrices are, what is an eigenvector, what is an eigenvalue, how these are related, and how these can be used to come up with the principal component, to find the principal components about the data. So we will cover enough maths which can help you to understand the algorithm or the technique better. So don't worry about that. But mathematical skills here mainly refers to the logical way of thinking. You should be able to think logically when you have a problem in your hand. So that directly refers to the mathematical skills. And the second is the programming skills, of course. Programming skills in the sense you should be comfortable to write some lines of code to solve a problem. Here, majorly, we will consider R as the programming. If you know SAS or Python, that is also fine. But this course considers R for practicals or solving the use case problems. And the next one is domain or functional knowledge. Yeah, domain or functional knowledge is important if you are going to solve a problem in say finance domain. So you should have a better knowledge or the basics of finance knowledge, the terms used in the industry, and who are the main actors to solve the problem. So that kind of domain perspective knowledge also is required while solving a data science problem. And apart from these three skills, we have two more important skills, which are nothing but the communication skills and the visualization skills. Because after doing your analysis and find and building your model, you need to present your findings either as a dashboard or some kind of graphical representation. Because for most of the times the interested users for a data science solutions will be the high level people of an organization, where you cannot explain the code you have built because they might not understand the language or the about the tool. Just they want to uh, evaluate your results is based on some kind of graphical or visual representation. So a kind of visualization skills also required as part of the data scientist. Also, you have to have a good communication skills to tell your story in the sense whatever how you started after considering the business use case, what was your approach, what kind of data you have collected, how you have interacted with the business, how you got the domain or details into your business, and what was your approach, what models you have chosen. So you should be able to communicate your story very effectively. So a communication skills also plays an important role for a data scientist, apart from the mathematical programming domain and communication skills. In fact, visualization and communication skills are at most important sometimes, irrespective of years of level of experience and your academic background. And we highly recommend you to build these skills, at least to have these skills, in where you can claim yourself as a perfect data scientist.